Hello everyone, myself Vibhu. Today I am going to discuss about kinetic energy. This is one of the most important basic topic we must learn from the school level as well as in the 11th classes. So ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿದೆ ಈ ಟಾಪಿಕ್. ಯೂಶುವಲಿ 3 ಮಾರ್ಕ್ಸ್ಗೆ ಕೇಳ್ತಾರೆ. ಇಲ್ಲ ಸಮ್ ಟೈಮ್ ದೇ ವಿಲ್ ಆಸ್ಕ್ ಫಾರ್ 1 mark or 2 mark or 3 marks. So it will come in all the aspects of physics. So wherever we are going to study about energy, there and all this will appear, come and go. ಅಂದ್ರೆ ಇದೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ ಅಂತ ಹೇಳ್ಬೋದು. ಸೊ ನೋಡೋಣ ಇದನ್ನ ಹೆಂಗ್ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು ಅಂತ ಹೇಳಿ. ವಾಟ್ ಈಸ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ? ಸೊ ಇಟ್ ಈಸ್ ಎ ಕೈಂಡ್ ಆಫ್ ಎನರ್ಜಿ ಗೇನ್ಡ್ ಬೈ ದ ವರ್ಚ್ಯೂ ಆಫ್ motion. Any body which is in the motion, then we can say that it is having the kinetic energy. For example, a rolling ball, a car moving, a kite flying, aeroplane is flying, a moving bullet, a, a falling coconut from the tree. Anything which is under motion is having kinetic energy. All right. So now we have to prove this with the derivation. We'll see this step by step. Okay. So let's start with the definition here. So what is kinetic energy? So for that, I can write it here. It is a kind of energy possessed due to the virtue of motion. Virtue in the sense because of that only. ಯಾವ ಬಾಡಿ ಮೋಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೋ, ಯಾವಾಗ ಮೋಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೋ ಅವಾಗ ಅದರಲ್ಲಿ ಕೈನೆಟಿಕ್ ಇದೆ, ಎನರ್ಜಿ ಇದೆ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕಾಗುತ್ತೆ. ಸೊ ವರ್ಚು ಅಂದ್ರೆ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಅಂತೇಳಿ. ಓಕೆ, ಹಿಯರ್ ಎಕ್ಸಾಂಪಲ್ಸ್. Anything which is under the motion is having the kinetic energy. For example, a bullet, fired from a flowing water, any water like in the river or the lake, wherever the water is flowing, the tap, in the dam, wherever water is flowing, then we can say that it has kinetic energy. A moving car, a rolling ball, anything we can say it has kinetic energy. So this one we have to prove mathematically. So how we can prove this? So for this, we'll consider a one diagram here. Okay, just imagine this is a plane here. And initially there is a one body which is having the mass m. Okay, mass is the basic property of a body. Every body has the mass initially which is at rest, and we'll consider the position of the body is A. Now what we will do, we'll apply a force on this body. Okay, the body is having the mass m which is located at the point A and which is applied by the force F. When a force is applied on the body will get displaced from point A to point B. And from here to here, the displacement of the body is considered as S. and initially the body was at rest. So initial velocity is taken as u. Then once the force is applied, the body gets displaced from A to point B. And now the body is moving with a velocity v. V is considered as a final velocity. Okay, here F is the force. M is the mass. U is the initial velocity. V is the final velocity. S is the displacement of the body. All right. This can be proved mathematically here. Okay. Let's consider a kinematic equation. Let's consider a kinematic equation, that is v square minus u square equals 2as. Here a is the acceleration. Okay, so we know that initially the body was at point A having the velocity u. After applying the force F, it got displaced to the point B and it will start moving with the velocity v. So there is a change in the velocity. Then when the body is having the change in its velocity, then we can say that it has its acceleration A. So that can be written here as v square minus u square equals 2as. As I said that the body is initially it was at rest. So initial velocity is taken as 0 equals 2as. So now from the above equation, I can write it as a equals v square divided by 2s. Now, by Newton's second law of motion, F equals ma. So as I said in the earlier, we have applied the force F. Then the body is having the mass m and it has the acceleration a. Now let us call this as the equation number 1, and we'll call it as the equation number 2, and we'll call this as the equation number 3. Now use equation 2 in 3. So now what will happen here? In the place of A, I will substitute v square divided by 2s. So now what will happen? F equals m v square divided by 2s. And as I said from the figure, when you apply the force F, the body gets displaced from A to B. There is a displacement, yes. So we can see here force is applied and there is a displacement. Then altogether, I can say that there is a work done. Now, work done on the body is, we'll consider this as a fourth equation. That is W equals F into S. We'll call it as a fifth equation. So work is the product of force into displacement. Now use 4 in 5. So now what will happen? W equals F means what here? m v square divided by 2s into s, right? So now what will happen here? Where s and s will get cancel each other. So and finally we left out with half mv square. This work done on a body is taken as kinetic energy. So then kinetic energy equals half mv square, where m is the mass of the body, v is the velocity of the body. So basically the kinetic energy depends on mass and velocity. And SI unit of energy or kinetic energy is joule. All right. And here is the expression for kinetic energy. Okay. This is the final expression for kinetic energy. Still, if you want to furthermore continue in saying that the relation between kinetic energy and linear momentum is, so we know that kinetic energy equals half mv square, but the linear momentum can be taken as p equals mass into velocity. Linear momentum is the product of mass and velocity. Now what I will do here is the kinetic energy equals what? Half mv square. In this equation, I will multiply and divide by m. So when we multiply and divide it by m on the RHS of this equation, so it will become half mv square, which is multiplied by mass and divided by m. So next, what will happen in this equation now? 1 by 2 m square v square divided by m. So then I can write it as here, the kinetic energy can be written as half, where m and v is taken as p, right? So now what will happen here? So instead of that, what I will write here, mv whole square divided by m. That is nothing but 1 by 2 p square divided by m. So finally what we can write is kinetic energy can be written as p square divided by 2m. This is the relation between kinetic energy and linear momentum. So furthermore what we can write is p square equals cross multiply 2m into kinetic energy. Right? So furthermore, what I can write is P equals the square root of 2m into Ke. So this is the relation between linear momentum and kinetic energy. Hopefully this video is very clear. If you have any doubts and questions on this, you can post me in the comment section. Thank you very much for watching this video, and kindly share with your friends and one who is in the need. Thank you very much.